given that A occurs. The probability that event B occurs given that event A occurs. It is written as, look at the capital P probability, B given A. So this little bar means given that. That's what that bar means. Put in quotations. B given that A. The probability of B given that A. It'll be first. On one and another. Third word. Let me show you what I mean by conditional. Conditional means like under the conditions of. For instance, if I ask, how many of you want Mexico to win the World Cup? Under the conditions if you're a guy. Under the conditions that you're a guy. So notice I took the sample space and I reduced it just to the guys. You need to go back to math 1. How many people in here are Dodger fans given that you're female? I've now taken the sample space, you guys, and I've lowered it to the 2 females in here. So conditions lower the sample space. You get the sample space, and now I want to focus in on the ones who are under these conditions, the females or the males, or the ones who are over 18, or the ones who are over 50, or what's the probability of you getting cancer from taking aspirin if you're under 70 years old? See, all these conditions take sample spaces and they limit them. So watch this with a card example. Example 3.
Just notice for the World Cup, I don't think they have a main song, do they? Like for 2010 with
Example 3. Mudio, ready? Example 3. Here we go. Find the probability. You have your notes section. So you have the back area. You have the bottom area. This is example 3. We did 2 examples this morning. This is example 3. Find the probability. Watch this now. Of getting a red card and then getting a black card right after. But look what I'm put, with replacement. What do I mean by that, with replacement?
So you flip it, or you take them out, and you put them back in.
Right, so after you get the first card, you put the card right back in the deck. Then you pick the second card.
So they're making it independent.
Okay, so Jovanovic is already talking to independent, dependent. The question is this independent or dependent? You're saying independent. Why? You're replacing the cards so the deck doesn't change 52 cards. So this would be an independent case. So let's see here. All right. So how many red cards are there in the deck?
Those.
Good try.
Wait. Oh, red card. Oh.
How many reds? 13. All right. Anybody else? How many red cards are in the deck of cards? 26, huh? Because there's 2 suits. The diamonds are red and the hearts are red, so 13 and 13 is 26. So here we go. This is independent event, so I'm going to use the independent formula that we did this morning. The probability of A and B is equal to the probability of A times the probability of B. Let's do it. Here we go. The probability of red, getting a red card, we're replacing that puppy, and then getting a black card. Let's see. In that order, I got to get a red, replace it, then get a black. What's the probability? Let's see. A red, we just said is 26 out of 52 times. How many blacks are there?
26.
There's also 26 blacks. It's the spades and the clubs. It's 26. So I'm going to multiply these puppies. So 26 over 52 times 26 over 52. These are independent events. Let me multiply it. Here you go. 26 times 26. 676. Over 52 times 52. I get 2704. 2,704. Let me convert that to a decimal. Before I convert to decimal, think about what this means. This fraction means this. You getting a red card, putting it back in the deck, then getting a black card, that'll happen. That will happen 676 times out of 2,704 trials, approximately. Good. This would be theoretical. We can sit here with a deck of cards and try it maybe the whole summer school. 2,704 times trials. It's 25? Let's see. 676 divided by 2,704. You're the man. 25% chance. 0.25. So at a 25% chance this will happen if you do this with a deck of cards. Right, Rodriguez?
They're just not what it's.
That's what we're going to do now. That takes us to our topic of conditional probability. This bar, what the heck is given that? That's weird. That's funky notation. Let's see what that means. Here's example 4. Example 4 is the same thing, but now without replacement. So let's get what's the probability of getting a red and then a black without, I'm not going to write out without, I'm going to put W/O, without replacement now.
Can you do both with and without?
How would that look? Me neither. Let me know when you, but I don't know. You let me know if you find. Yeah, I'm not an illogical teacher though. You're saying do it and not do it? I don't know. Let me know. Uh-oh. Jovanovic is there already. Watch this now. Watch this. Just a second. Yes. Turn your page over. Look at the formula now for conditional probability. Yeah. So this is dependent events now. If I take a red card out and don't replace it, I have now shrunken the sample space to not 52 cards, but to 51 cards. So we're dealing with a dependent event. This event depends on me getting the red card. So look at the dependent events formula. It says the probability of A and B is equal to, watch this now, it's right there in front of you. The formula is there, so you don't have to write this down. I'm just writing it down for our sake. The probability of A times, watch this now, the probability of B given that A occurs. B given that A actually happens. That's what this bar is, given that, under the conditions of, assuming that. The probability of B assuming that A happens. So watch this now. Check it out. So example 4. Let me apply the formula now to the situation of us getting a red and a black card. The probability then, let me put it in red.
Yeah.
Actually blue. The probability of me getting a red and a black card without replacement is going to equal to me, the probability of getting a red times the probability of getting a black, given that red happens. Let's plug and chug now. probability of getting a red, Yonovich? 26 reds out of 52 cards times now, watch this now. I didn't replace that red card. I got the red card. So this is going to be how many black cards with one card missing? Help me, Munoz. Okay. So watch this. This means without replacement, right? So imagine me having a deck of cards. I take one, I get the red, and I don't replace it. How many cards are left in the deck? 51 now, right? Not 52. So watch this now. But there's 26 black cards still, right? The clubs and the spades. And look at the sample space is now lowered to 51. This is the probability of getting a black given that I took a red. The red actually was taken out. Given that this occurred. So I have the stack in front of me, the deck. Take it out, boom, that's 26 out of 52. I put the card in my pocket. I don't put it back in the deck. Now, the probability of me getting a black now with that same deck is 26 out of 51.
It's just relax, which actually more.
Let's see. Should be a higher percentage. Let's see. There you go. I'll multiply this. That's going to be 676. What's 676?
Yeah.
Yeah. Same numerator, but smaller denominator, huh? 26. Okay. Thank you. So it should be a higher probability. If you don't replace that card, it should be a higher probability.
It's still 0.24, but 0.24, 0.25, 0.25. 0.35.
0.4. Okay, that's good. Thank you for bringing that up. It's still 0.25, but the third decimal. Notice. Well, I'm going to round to the nearest percent. So look at, if I round the nearest percent, it's 0.25 as a decimal. But it's not the same because if I express this as a percent to the nearest tenth, this is actually 25.4%. Because this is 25%, this is a hundredths place. This would be a decimal, a tenth of a percent. So it's really a higher percentage probability than just purely 25% with the replacement. So because we have that extra decimal there, that means there's a higher probability of this happening versus without replacement. So it's more likely when you replace the card to get the black card after. Let's try one with a different situation. So, again, if I round it just to the decimal, it looks like it's going to be the same probability as example 3. But it's really not, technically, because you have a four digit now. So if we round it to the nearest decimal, it looks the same, but if we round it to the nearest tenth of a percent, it's 25.4%. Say again? Slightly more though, huh? And the reason it's 4/10 more of a chance because we put the card back in. Or no, because we took the card out. We kept the card. That's the other way around. One more example. Example 5.
Not bad.
You don't have to draw the bag of marbles here.
This is the last one?
Last one. Find the probability of getting a blue, because they're better than reds, and a red marble without replacement. Huh? I think so. Don't tell anybody. All right. Without replacement. So this would be a dependent event. So I'm going to use a conditional probability formula, the one on the second page. The probability of A and B happening. Me getting a red, though, depends on me getting a blue because I'm not replacing the marble. So the sample space will shrink. So this is a dependent event, so it's going to be the probability of A times the probability of B given that A happens. All right. So the probability of getting a blue would be my probability of A. So 2 over 7
5 over 7.
times
5 over 7.
5 over 7 or 5 over 6?
5 over 7, because it's without replacement.
Right. So I keep the marble.
Oh, that's what it is.
So there's 5 over, now look at the sample space is shrunk into 6 because I kept the marble. This is the probability of me getting a blue, or actually of me getting a red, given that I got a blue the first time. I kept the blue. So this is a key word right here. With replacement or without replacement really depend. It determines whether it's a dependent or independent situation. You got to be kidding me. Multiplying by fractions in math too? This is junior high school stuff or middle school stuff. That's going to be 10 on the numerator. 7 times 6 is 42. 10 divided by 42?
0.238.
0.238. So I can call that in percentage, this would be 23.8%. Or as a decimal to the nearest hundredth, right, as a decimal to the nearest hundredth, it'd be 24.024.
Which mark are wrong if like we don't round up?
Heck yeah. It's fun when I mark things wrong. Just kidding. So here's a percentage, decimal, or I could have rounded this to the nearest whole percent. Keep in mind, because again, this is a hundredths place, so rounding to the nearest whole percent would have been 24%. But this would be rounding to the nearest tenth of a percent, 23.8%.
So the answer is 23.
Well, for your when you get to assignment 27, sometimes they ask for this answer. Sometimes they'll ask for percent to the nearest tenth. You'll start seeing, because you're going to type them in, because it's an online assignment when you get to 27. Say again? There will be a 28 later, second half. Okay. We have a good 20 minutes. Make use of your time.